What if I told you there is no such thing as sound? What you think of as noise is actually a physical touch. When you hear a drum, that drum isn't just making a noise, it is literally punching the air, and that punch travels across the room to hit your eardrum. Have you ever wondered why you can see lightning before you hear thunder? Or why, if you screamed in space, no one would hear you pass out? Today, we're breaking down the invisible physics of the world's most overlooked energy source. We live in a noisy universe. From the hum of your computer fan to the voice reading this video, sound is everywhere. But unlike light, you can't see it, you can't hold it. So what is it? If you zoom in on the air around you, it isn't empty space. It is a soup of trillions of invisible molecules floating around. Sound is simply what happens when something pushes those molecules. Welcome to InnoVision Tech. Let's find out how the world speaks to us. Imagine a line of dominoes stretching across a table. If you push the first domino, it hits the second. The second hits the third. The movement travels all the way to the end of the line. But here's the key. The first domino didn't travel to the end. It just stayed in place and passed the energy along. That is exactly how sound travels. When a speaker cone vibrates, it pushes the air molecules right in front of it. Those molecules smash into their neighbors, passing the energy on, and then bounce back to their original spot. This creates a pressure wave. It's a chain reaction of collisions. So technically, you don't hear a speaker. You feel the air molecules that the speaker pushed. But this chain reaction takes time. Light is almost instant. It travels at 300,000 kilometers per second. Sound is lazy. It only travels at about 343 meters per second through air. This is why at a baseball game, you see the batter hit the ball before you hear the crack of the bat. The light reached you instantly. The sound wave had to crawl its way through the air molecules to get to you. But here's a weird fact. Sound travels faster through solids and liquids than it does through air. Why? Because the molecules in water or steel are packed tighter together. The dominoes are closer. The chain reaction happens faster. If you put your head underwater, sound travels 4 times faster than in air. If you put your ear against a steel railroad track, you would hear the train coming miles before you heard it through the wind. Now, let's go to space. Sci-fi movies love to show spaceships exploding with a massive boom. In reality, a space battle would be completely silent. Remember, sound is a mechanical wave. It needs a medium. It needs molecules to push. Space is a vacuum. It is empty. There are no dominoes to knock over. You could detonate a nuclear bomb next to a spaceship, and inside, the astronauts wouldn't hear a thing. Without matter to carry the vibration, sound simply ceases to exist. So how do we actually decode this energy? Your ear is one of the most complex pieces of biological engineering in existence. When that pressure wave hits the side of your head, it travels down the ear canal and hits the eardrum, a tiny piece of tight skin. The eardrum vibrates, shaking 3 microscopic bones, the hammer, the anvil, and the stirrup. These bones act like a mechanical amplifier, boosting the signal and sending it into a fluid-filled spiral called the cochlea. Inside the cochlea, tiny hairs turn that liquid movement into electrical signals. Your brain takes that electricity and says, "That's a Mozart symphony," or "That's a car horn." You are literally turning air pressure into information. But your ears have limits. Just like there's light we can't see, like ultraviolet rays, there's sound we can't hear. This is called the frequency spectrum. Humans can hear vibrations between 20 and 20,000 times per second. Anything higher is called ultrasound. Bats use this to see in the dark through echolocation, and doctors use it to look inside the human body without cutting it open. Anything lower is infrasound.
Whales use these deep, rumbling waves to communicate across entire oceans, and earthquakes generate them moments before the ground shakes. The world is full of noise. We're just tuned in to a tiny channel of it. Since this is InnoVision tech, how do we capture this? A microphone is just a robotic ear. Inside your phone, there's a tiny diaphragm. When you speak, the pressure wave from your voice hits that diaphragm and vibrates it. The phone turns those physical vibrations into electrical signals, literally translating your voice into digital code. When you play it back, the speaker turns those electrical signals back into physical vibrations. It's magic disguised as engineering. We're freezing a moment of energy and replaying it later. Sound is more than just noise. It's the vibration of the universe itself. It's the way energy moves through matter. It connects us, warns us, and entertains us. Next time you put on your headphones, remember, you're not just listening to music. You're letting a magnet punch the air molecules into your ear canal, and your brain is turning that physics into feeling. If you learned something new about the invisible world today, hit that like button. Subscribe to InnoVision Tech for more deep dives into the science that powers our lives.